Hello. Let's apply the general method to draw regular polygons inscribed in circumferences or circles. The first step we must do is to draw a vertical diameter. This vertical diameter will intersect our circumference at 2 points A and P as shown. Now, with your compass centered on point A as shown, scribe an arc to the right. Now, repeat this process, but this time use point P to center your compass and scribe an arc to the left, which intersects the previous arc as shown in the video. Where these arcs intersect, we will call this point Q. Our next step is to divide the diameter we drew previously into as many parts as we want our polygon to have sides. For example, in this case we want to draw a decagon, or a 10-sided polygon. So we have to divide the diameter into 10 equal parts. So to divide the diameter into 10 equal parts, we will use Taylor's theorem. First, we draw a line starting at point A with any angle to the vertical diameter as shown. After that, we will choose any given measurement, for example 2 centimeters. And set your compass to 2 centimeters and now scribe 10 equal lines as shown. You can also do this using a ruler. Just remember that accuracy here is very important in this part of the exercise. As you can see, point 8, now we'll scribe point 9, and our last point, point 10. When I have my 10th division marked as shown, we then join this mark to point P on our vertical diameter. From now on, we will draw parallel segments to the previous junctions as shown. We can use our 45 and our 90-degree set squares to help us with this task, as you won't have this software used to record these videos to help you draw perfect parallel lines. So here we continue drawing our parallel segments. And as can be seen here, when you're drawing your 5th parallel, it should go exactly through the center point 0. This means that you're doing everything correctly and accurately. And it should always happen when you divide the diameter into an even number of sides. Now continue with point 4 and point 3. And next, point 2, which is very important. Point 2, we will draw this line thicker to show its importance. Because regardless of the number of sides of the polygon we are looking to draw, the line marked number 2 on the diameter will always be the key point. And we will mark it number 2. The next step is to draw a line from point Q to point 2 and continue to point B on the circle as shown. Okay, so we have an arc AB, and this is the measurement of one side of the decagon we are looking for. So now this arc AB should fit exactly 10 times into the circumference of the circle, if we have drawn everything precisely up to this point. So now, using your compass as shown, proceed to mark 10 arcs of length AB on the circumference. At this point, I just want to remind you that this is the general method to draw a polygon with any number of sides. The only condition is that they are inscribed in a previously drawn circumference. The only difference between exercises will be the division of the diameter, according to the number of sides we want our polygon to be. But whatever the number of parts, the key division on the diameter will always be point number 2. So as you can see, we continue scribing our arcs AB onto our circumference. As shown in the video, we will label each point A, B, C, D, E, F until point I. This means everything is correct and we're working with accuracy. Each point will be a vertex of the decagon. The distance from the last point to point A should be the same as shown if everything is drawn correctly. So finally, now we join the vertices as shown: A to B, B to C, C to D, E to P, and we continue F to P, F to G, G to H, H to I, and finally closing the polygon by joining vertices I to A, until we have the perfect decagon in which we were looking for. I hope this helped you. Thank you very much. Hello, let's draw an equilateral triangle inscribed in a given circle. As you can see, we have drawn a circle with its center O. The first thing we are going to do is to draw a vertical diameter. This vertical diameter cuts the circle at 2 points, which we call A and P. As can be seen here in the video. This point A is going to be the first vertex of our equilateral triangle. So the next step is to set our compass to the length of the original circle, and centering our compass on point P, the bottom of our vertical diameter, we are going to draw an arc which intersects our previous circle at 2 points, which we will call B and C, as can be seen here in the video. These are the two remaining vertices of our equilateral triangle. So now, finally, we just need to join these vertices. Or B with C, C with A, and finally A to B. So here we have our equilateral triangle inscribed in a given circle. I hope this video has helped you. Please press like or subscribe to our channel. Thank you. Hello, let's draw a square inscribed in a given circle. The first step is to draw a vertical diameter, as shown here. This diameter intersects the circumference at 2 points, which we will call A and C. The next step, we draw another diameter, this time perpendicular to the previous diameter. You can do this at home using your 45-degree or 60-degree set squares or using the perpendicular bisector of the first diameter method. In this video, I use special software with a 45-degree set square with an incorporated protractor. Our second diameter will intersect our circumference at points B and D, as can be seen here in the video. So now, the last thing I need to do is obtain my square, is to join the 4 vertices. From B to A, from A to D, from B to C, and finally, we will finish our square joining points C to D. So now we have our square inscribed in a circumference, in this case supported on one of its vertices, C. I hope this video has helped you. Thank you very much. See you in our next video. You can click like or subscribe to our channel. Thank you. Hello, let's draw a regular pentagon inscribed in a given circumference. The first thing we are going to do is to draw a vertical diameter, which cuts our circumference at points A and P, as can be seen here in the video. The second step is to draw a horizontal diameter, perpendicular to our previous diameter. To do this in the video using the 45-degree set square with an attached protractor, but you at home can work out the perpendicular bisector of the diameter AP or use your 45 and 60-degree set squares. Our new horizontal diameter will cut our circumference at 2 points, which we will call Q and R. We will demonstrate that these two diameters are perpendicular by placing our perpendicular symbol, as can be seen here. So the next step, we are going to calculate the perpendicular bisector of the line segment OR. To do this, I remind you, we must draw 2 arcs with the same radiuses. These radiuses must be longer than half of the line segment, as shown here in the video. The centers of these 2 arcs are O and R. These 2 arcs intersect at 2 points, and now we will join these 2 points, and where it cuts the radius OR, this will be the midpoint M of the radius. So now, with our compass centered on M and radius MA, we scribe an arc to the left until it cuts our horizontal diameter QR. We will call this point S. So now we join point S to point A with a thicker line, and this line segment SA will be the length L of one side of our pentagon that we want to draw. So the next step is, with our compass, we want to transport our length L onto our circumference 5 times, starting at point A. So as you can see, we scribe our first point. Now setting our compass on this point, we scribe our second point. Again, following this process, we set our compass on our third point and scribe our fourth. And again, setting our compass on point 4, we scribe our next point. And finally, if we are doing everything with precision and accuracy, our final arc should cut exactly on point A, as can be seen here in the video. So the next step is to name the final 4 vertices of our pentagon: B, C, D, and E. And finally, with a thicker line, we will join our vertices: A to B, B to C, C to D, D to E, and finally, so now we have our regular pentagon inscribed in a given circumference, joining our last vertices E to A. Thank you very much. Please subscribe to our channel or click like if you have this video has helped you. Thank you. Hello, let's draw a regular hexagon inscribed in a given circumference. The first step, we are going to draw the vertical diameter which cuts the circumference at 2 points, A and D. So the next step, with our compass set to the length of the radius of the circle and centered on point A, we scribe an arc which cuts the circle at 2 points, as can be seen here in the video. Now with our compass centered on D, we repeat this process and we cut the circle again at 2 points. As shown here. As can be seen, our 2 arcs pass through our center point 0. So now we have the 6 vertices of our regular hexagon inscribed in a circle. So finally, the last step is to join our vertices B to A, B to C, C to D, D to E, from E to F, and finally we close our hexagon joining points A to F. I hope this video has helped you. Thank you very much. See you in our next video. Please click like or subscribe to our channel. Thank you. Hello, let's draw a regular heptagon inscribed in a given circumference. The first step is to draw a vertical diameter which cuts our circumference at points A and P, as shown here in the video. So the next step is to set our compass to the radius of the given circle, and now with our compass centered on point P, we are going to scribe an arc which cuts our circumference at 2 points, which we will call Q and R. So the third step is to join these points Q and R with a horizontal line, as we can see here in the video, and this line cuts our vertical diameter at a point we will call M. So now we already have the length of one side of our heptagon, which is equal to QM or MR. So the next step is setting our compass to the length QM, for example, which we will set our compass, and we will put our compass on point A of the circumference and continue to scribe 7 arcs, which will be the vertices of our heptagon. So here we have our first arc. Now setting our compass on the previous arc, we scribe our second arc. Here we have our third. Here's our fourth arc. This is our fifth. And if we have been working with precision and accuracy up to this point, this is our sixth arc. And now our seventh arc should cut A exactly, if we have been working with accuracy, as can be seen here. Okay. So now we have our 7 vertices of the heptagon we are looking to draw. We will name them A, B, C, D, E, F, and G. And now the final step is to join our vertices from A to B using our ruler or our set square. from B to C, from C to D, from D to E, from E to F, from F to G, and finally we will close our pentagon from G to A. So now we have our regular heptagon inscribed in a given circumference. I hope this video has helped you. Thank you very much. Today we are going to draw a regular octagon inscribed in a given circle. Firstly, we are going to draw a square inscribed in this circle. To draw this, firstly we draw a vertical diameter and then a perpendicular diameter which forms a cross in the circle as shown. You can do this at home using your 45 and 60 degree set squares or using the perpendicular bisector of the first diameter method. In this video, I use special software with a 45 degree set square with a protractor in the center. So now we have already obtained the 4 vertices of the set square. We can join these 4 vertices to complete our square. So when we join these 4 vertices, as can be seen here, we obtain a perfect square. So the next step, we must calculate the perpendicular bisector of 2 adjacent sides. For example, the top 2 sides. Once again, I remind you to draw the perpendicular bisector of a line segment. We must draw 2 arcs with our compass centered on both ends of our line segment. And the radius of the arcs must be longer than half of the length of our line segment so that our 2 arcs can intersect. The resulting perpendicular bisector is the line which goes through the intersection of our previously drawn arcs. While we are drawing our second arc, we will continue the arc as we will use it again when calculating the perpendicular bisector of the second side, as can be seen here in the video. So now we have the 3 arcs which are necessary to draw our 2 perpendicular bisectors, as can be seen here. Here's the first one. And now we draw the second one. Where our 2 perpendicular bisectors intersect the circle, these 4 points are going to be the last 4 vertices of the octagon that we are looking to draw. So now we label our vertices A, B, C, D, E, F, G, and H as shown. So the last step is to join the 8 vertices of our regular octagon inscribed in a circle. So A to B, B to C, C to D, D to E, E to F, F to G, G to H, until finally we complete our octagon, H to A. I hope this video has helped you. Thank you very much. See you in our next video. You can click like or subscribe to our channel if you like. Hello, today we are going to draw a nonagon or a 9-sided polygon inscribed in a given circle. The first step is to draw perpendicular vertical and horizontal diameters, as can be seen here in the video. I do this using a 45-degree set square with a built-in protractor. And as you can see, we cut our circumference 4 times at points A, R, P, and Q. And we also prolongate our horizontal diameter to the right of the circle, as can be seen here in the video. So now, setting our compass on point A and setting it to the length A0, we scribe an arc to the right until it cuts our circumference at point 1. So now, we continue by setting our compass on point P, and with a radius P1, we scribe an arc to the right until it cuts our prolongated diameter at a point we will call 2. So now, with the same radius and setting our compass on the new point 2, we will scribe an arc to the left which goes through point A and point B, cutting our horizontal diameter at a new point which we will call point 3. So the distance from point Q to point 3 is going to be the length of the side of the nonagon, or the 9-sided polygon that we want to draw. So now, setting our compass to the length Q3, we are going to scribe 9 arcs on the circumference. So as you can see, we set our compass to the length Q3, which will be the length of the side of our nonagon. And now, setting our compass on point A, we scribe our first vertex. And again, with the same radius, setting our compass on the previously scribed vertex, we scribe our second. Here we have our third arc, and setting our compass on this. It's our fourth. Again, setting our compass on our previously scribed arc, we scribe our fifth. Continuing the process, setting our compass on our previously scribed arc, we scribe our sixth. And again, setting our compass on our previously scribed arc, we scribe an arc to the left, cutting the circumference. It's our seventh. Now we scribe our eighth arc, and as can be seen, if we're working with precision and accuracy, our ninth and final arc should cut our point A perfectly. As can be seen here, setting our compass on the previously scribed arc, our final arc should cut exactly at point A if we're working with precision and accuracy. The next step is to name our points A, B, C, D, E, F, G, H, I. These are the 9 vertices of our nonagon. So the final step is to join them, A to B, B to C, C to D, D to E, E to F, F to G, G to H, H to I, and finally we close our nonagon, joining I to A. So, I hope this has helped you to draw a nonagon inscribed in a given circle. Please click like or subscribe to our YouTube channel. Hello. Today we are going to draw a regular decagon inscribed in a given circumference. We are going to do this decagon not using the general method which is previously done, but we are going to draw a 5-sided pentagon and then we are going to duplicate its sides so that we form a 10-sided polygon or decagon. And also by using this method we can duplicate any polygon to double its amount of sides, for example from a hexagon to a 12-sided polygon or from a heptagon to a 14-sided polygon. The first thing we are going to do is to draw a horizontal diameter which cuts our circumference at points P and Q, as can be seen here in the video. The second step is to draw a vertical diameter perpendicular to our previous diameter. Our new vertical diameter will cut our circumference at 2 points which we will call A and F. So the next step we are going to calculate the perpendicular bisector of the radius OQ. To do this, with our compass set on point O and a radius slightly greater than half of the radius OQ, we scribe an arc above and below the radius. And now, with the same radius and the compass centered on point Q, we scribe another arc which intersects our previously drawn arcs at 2 points. And now, we will join these 2 points, and where it cuts the radius OQ, this will be the midpoint R of the radius. So now, with our compass centered on R and radius RA, we scribe an arc to the left until it cuts our horizontal diameter PQ. We will call this point S. Now we join point S to point A, and this line segment SA will be the length L5 of one side of the pentagon that we want to draw. So the next step is, with our compass set to the length L5 and centered on the point A, we scribe an arc to the left, cutting our circumference at point C, as can be seen here in the video. So now, with our compass set to the length AC and set on the point A, we scribe a new arc to the right. And now, setting our compass on this previously scribed arc, we're going to scribe another arc below, as can be seen here. And now setting our compass on point C, our previously drawn arc C, we scribe another arc below, as can be seen here. If we are doing everything with precision and accuracy, our final arc should fit exactly as you can see here in the video. And we will name these points L, E, G, and C, as can be seen here. So we are going to draw our pentagon in blue to differentiate it from the final decagon that we are going to draw. To continue, from our pentagon, we are going to work out the perpendicular bisector of one of its sides, for example, AC. While drawing the perpendicular bisector of AC, remember we must set the compass length to slightly greater than half the radius AC, and then we scribe an arc above and below the radius. And now, with the same radius and the compass centered on point A, we scribe another arc which intersects our previously drawn arcs at 2 points. And now we will join these 2 points, and where this line cuts the circumference above the side, this will be our new vertex B of the decagon. So now the distance from vertex A on our pentagon to vertex B on our decagon is going to be the length of one side of our new decagon. So now, with the compass set to the length AC, we are going to scribe 3 further new arcs on the other sides of our pentagon, excluding the bottom one because it is already marked with the vertical diameter. So now, with our compass set on point A, as can be seen here in the video. And now again, with our compass set on point L, we scribe another arc on our circumference, as can be seen here. And now we are going to mark these new vertices B, D, H, and J, as can be seen here. And finally, the next step is to join our points A to B, B to C, C to D, D to E, E to F, F to G, G to H, H to L, L to J, and finally we will close our decagon joining points J to A. And remember that we can use this method to duplicate any polygon to double its amount of sides. So here you have a regular decagon inscribed in a given circumference. I hope this video has helped you. Please press like or subscribe to our channel. Thank you. Hello, let's draw a decagon or a 12-sided regular polygon inscribed in a given circle. The first step is to draw two perpendicular diameters, one vertical and one horizontal, as can be seen in the video. We can do this in two ways, using our set squares or working out the perpendicular bisector of the first diameter. So the next step, setting our compass to the length radius of the circle, we are going to draw four arcs using the extremities of the diameters as centers. So setting our compass on the top of the vertical diameter, we scribe a semicircle, cutting our previously drawn circle at 2 points. Now setting our compass on the left side of the horizontal diameter, we scribe another semicircle, cutting our circle at 2 points. And again, setting our compass at the bottom of the vertical diameter, we scribe our third arc, cutting the circle at 2 points. And finally, setting our compass on the right side of the horizontal diameter, we scribe our fourth arc. With these four arcs, we obtain 8 of the 12 vertices of our decagon, and the other 4 are the extremities of the diameters. We name these points from A to L, and the only step left is to join the points. So we'll join vertex A to B, B to C, C to D, D to E, E to F, F to G. This process is based on drawing two regular inscribed hexagons. G to H, H to I to J, J to K, K to L, and finally we close our 12-sided regular polygon by joining vertex L to A. So here we have the regular 12-sided polygon inscribed in a given circumference. I hope this video has helped you. Thank you very much. Please press like or subscribe to our channel. Thank you.